Okay, so today we're looking at electrochemistry. So when we are converting, really? There. When we're converting chemical energy into electrical energy and vice versa, it is known as electrochemistry. Okay? And all electrochemical reactions have one thing in common. They involve the transfer of electrons from one reactant to another. Okay? And there are a couple of reactions that always involve electron transfer. Those would be synthesis and decomposition reactions. The other reactions that also fall into this category would be single replacement and combustion reactions. Okay? So when we have some sort of electron transfer between reactants, those are called oxidation-reduction reactions, and we abbreviate them as redox for short. Okay? Some reactions do not involve electron transfer at all. Double replacement reactions are the ones that do not. Okay? Sometimes synthesis and decomposition reactions that have compounds containing oxygen in them don't, but I'm going to leave that out for now. But reactions that don't involve electron transfer are called metathesis reactions. Okay, let's take a look at the next page. The way that we keep track of electrons being transferred in between reactants is by using something called an oxidation number. Okay, oxidation numbers are also called oxidation states. Okay, so they are these made up values that we use to keep track of what is accepting and what is giving up electrons, okay? And there are rules, and those rules are outlined in a table down here. Okay, so let me go over these rules with you. There we go. All right. For the first one, if you have an atom in elemental form, that means it's just that element symbol alone. It may have a subscript, so I'm going to write that here. So I'm going to write a single element that may have a subscript. Okay. They gave a few examples. For instance, Na would be elemental sodium, O2 elemental oxygen, P4 elemental phosphorus, As would be arsenic, Zn would be zinc. Okay? You cannot have a charge present. That would be an ion. Does that make sense? Okay? So what do we do with these oxidation numbers? Well, you typically write them above the symbol. So since these are elemental forms, their oxidation numbers are 0. So we typically write the 0 above the symbol. Okay? Second rule. If you have a monoatomic ion, the oxidation number is the same as the ion's charge. So if you want to get out your nomenclature periodic table that has the charges on it, we can use that as a reference. Okay? These charges should be on the paper already for you, but you can get out that periodic table because we're going to use it anyway. Okay, so here I've got K plus 1. The charge on potassium is a +1 here. That's a monoatomic ion. So you would put a +1 as its oxidation number. Does that make sense? Okay. For the next one, we've got Ca +2. So what would its oxidation number be? +2. How about the next one? We've got Fe +2. +2. The next one, you've got Fe +3. So what would that be? +3. And the last one is Cl -1. -1. Okay? Okay. Generally speaking, oxygen has an oxidation number of -2. Okay? The only time that oxygen has a different oxidation number is if it's peroxide, which is a polyatomic ion that's on the bottom left of your periodic table. Okay? In order to have peroxide, however, it has to be with a metal. So this right here would have to have a metal in front of it with an O2 after it in the formula. Then you would be suspicious that it's peroxide. Okay, and I'll show you that in an example. But peroxides have an oxidation number of -1. Okay, so that's different than if it's just oxygen at its usual -2. Also, if you have the formula OF2, then oxygen is a +2. Okay, so let's look at the two examples that they gave us. So in these two examples, we're strictly looking at the oxygen. We want to assign oxygen its usual oxidation number. Now, here I have sodium with an O2. Sodium is a metal. It's on the left-hand side of your periodic table, okay? And since O2 is attached to a metal, we should be suspicious that it might be peroxide. So the easiest way to figure this out is the oxidation numbers for the alkali metals, which are the first group on the periodic table. It's the same as their charge. It's a +1. And then if it's an alkaline earth metal, and this is not in the book, so you're going to want to write this down. Alkaline earth metals have an oxidation number that's the same as their charge as well, which is a +2. So if you can assign those metals their oxidation numbers first, then you can figure out if it's peroxide. Okay, so where is sodium on your periodic table? Is it an alkali metal or an alkaline earth metal? It's an alkali metal because it's in the first group, right? This is group 1. This is group 2. So we would put a +1 on sodium because it's in group 1. Yes.
I'm sorry, what did you say about alkaline metals?
Alkaline metals have an oxidation number that's the same as their charge, which is +1. Okay? No, that wasn't supposed to happen. I wonder if my computer just went to sleep. Yes. It's back? Yeah. Okay. Okay, so since I put the +1 on sodium, that means oxygen has to be a -1. And let me explain to you how I know that. The sum of the oxidation numbers in a compound has to add up to 0. So if sodium is a +1, and I have 2 of them, and I have 2 oxygens, oxygen has to be a -1. Does that make sense? Because this would be a +2 and a -2 adding up to 0. Okay? In OF2, what would oxygen's oxidation number be? +2. All right, next one. Hydrogen has an oxidation number that's pretty much the same as its charge, which is a +1. Okay? The only time that hydrogen is not a +1 is if you've got a metal attached to hydrogen. If you have that, then hydrogen is a -1. Okay? So let me give you an example. If you have water, water is H2O, oxygen is a nonmetal, so that means hydrogen would have an oxidation number of +1, which is the same as its charge. Okay? if I've got 2 hydrogens and a +1, isn't this a +2 overall over here? What would oxygen's oxidation number be? -2, because they have to add up to 0. Okay? Okay, let's take a look at the examples that they gave us over here. So I'm going to highlight the hydrogens in those formulas. And isn't calcium a metal? So here we have hydrogen attached to a metal. What group is calcium in? Is calcium an alkali metal or an alkaline earth metal? Alkaline earth metal. So what is the oxidation number on alkaline earth metals? +2. So that means hydrogen, since it's with a metal, must be a -1. Okay? For lithium hydride, lithium is also a metal. Is it an alkali metal or an alkaline earth metal? Alkali metal, so its oxidation number is +1, and hydrogen would be a -1 because it's with a metal. Okay? Okay. Let's take a look at the next example. So here we have CuCl and CuCl2. So, since chlorine is a halogen, halogens are typically going to be a -1. Okay, this is not in your book either. So you want to assign it a -1 first. So I'm going to assign chlorine a -1. So in CuCl, if chlorine's a -1, what would copper be? +1. In CuCl2, if I assign chlorine a -1, what would copper be? +2, because that's how you would add up to 0. Okay? Rule number 6. If you have a polyatomic ion, that means groups of symbols with a charge, then the sum of their oxidation numbers is the same as the charge that's on the ion. So ClO4 -1, we're going to assign oxygen because we know oxygen is the same as its charge, which is -2. So you're going to put a -2 on the oxygen here and here. Okay? We're going to solve for chlorine. Okay? Even though halogens are usually a -1, what you usually do is you assign the one that you know, and then you go back and you calculate the other one. So for ClO4, -1, what I'm going to do is I'm going to assign an X for chlorine. And we're going to use basic algebra to solve. So X plus, how many oxygens are here? 4 times -2, which is oxygen's oxidation number. These all add up to the charge on the polyatomic ion, which is a -1. Does that make sense? So X minus 8 equals -1. When you add 8 to the other side, X equals what? +7. So that means chlorine is a +7. For the next one, we have ClO3 -1. So assign an X. Let me do this in a different color. We're going to assign an X for this chlorine. So you've got X plus 3 oxygen, add a -2, add up to this -1 charge. So this is X minus 6 equals a -1. If you add the 6 to the other side, what do you get? 5. So that means chlorine's oxidation number is a +5. Okay? Number 7. Always assign the more electronegative element a negative oxidation number. So this is if you have like multiple elements in a compound and you're like, I don't know which one to assign first. So here, remember that electronegativity increases up and to the right on the periodic table. So that means fluorine is the most electronegative. So we would assign it its usual charge, which is a -1. And that means we're going to calculate phosphorus. Okay? If I assign an X for phosphorus, X plus 5-fluorine at a -1 adds up to 0, because that's a neutral compound. So that means I have X minus 5 is 0. So phosphorus is a +5, or its oxidation number. Okay? Last rule. If you have a compound or an ion with more than 2 elements in it, the element that is furthest to the right takes the most common oxidation number. Okay, so if I'm looking at SCN -1, what is the most common charge for nitrogen on the periodic table? -3. So you put a -3 on the N. Okay, and then from there, between sulfur and carbon, sulfur is more electronegative. You look at its location. So assign sulfur a -2, which is its usual charge, and then calculate the carbon. Okay? So this would be -2 for sulfur, plus, I'm going to use an X for carbon, plus a -3 for nitrogen. All of this adds up to the overall charge on SCN, which is a -1. So -2 and -3 are -5. Add the 5 to the other side, and you're going to get X is a +4. That means carbon has a +4 oxidation number. Okay? All right, let's practice doing this on the next page. So turn past the sample problem. And take a look at practice problems 1 through 8 with the person sitting next to you, and let's see what you guys come up with. Wait.
Okay, so oxygen has a sweet start. And then for CS2, so it doesn't have a charge. So okay, so O2. So that's -4. So then
Oh, wait.
where's our earth metal? So it's +1. So then it's +1.
Okay, let's have you guys be number 1. You guys are number 2.
I need to get some tissues.
In the back, you guys are 5. You guys are 6. You guys are 7.
I think it could be, because it's a metal and a
You're right. I am. You're right. Yeah. Put charges on it.
Okay.
I know, it's small. It's hard. Remember, the oxidation numbers have to add up to 0. So, yeah, on all neutral compounds. Yeah. Yeah, perfect. Thank you. Hydrogen, okay, for number 5. For number 5, if you've got 2 hydrogens here and a -2, that's what?
-4.
Yeah, does that add up to 0?
No, so it should be -1.
Yeah. All right, 7's fine.
No, we're not.
For number 4, there are 2 of them that you know. What are they?
NA and O.
Yeah, so if you assign those, use basic algebra to calculate chromium.
Plus 1. Yeah. And this would be X. Yeah. A -2. Yeah. And plus 1 is X -2.
So it would be, what just happened? Everything just shifted for some reason.
I think I moved it.
Hold on. Well, I can't see what it. Okay, now.
Equals.
Wait. See how you have 2 sodiums at a 1? Okay, so erase what you
Oh,
did.
do you have to do?
Yeah. So erase that. Okay, so now let's go back. In fact, erase. You can leave that, but you've got 2 at a +1, which when you multiply them would be
2.
yeah, 2 plus 2x.
Oh, you have to multiply so that.
And then this is minus 14 equals 0. Now solve for x.
Okay, so it's -1 plus 2x is equal to 0.
Yeah. So 2x is equal to 12. Yeah.
12.
Yeah.
X is equal to 6.
Yes. So you could erase this and write a positive 6 in there. Yeah.
Okay, that makes sense. Thank
Yeah.
you.
I have a question for number 6. You know that hydrogen is a +1. And this is a polyatomic ion, which means the oxidation numbers add up to this plus charge that's here on the paper. So if I assign nitrogen an X plus 4 times 1 is 4, it has to add up to 1. So then what would X be? -3, because you subtract 4 from each side. So that means that this nitrogen is really a -3. Does that make sense? Okay. All right, number 3. What do you know? Which one do you know? Like, the oxidation number of which one? O is...
-2, yeah.
So we're going to solve for C using basic algebra. Walk me through the equation. X plus what? 3.
Parentheses,
Yeah.
-2
Yeah.
equals, is it -2? Or
Yep. Equals that negative charge. It's there on the paper because it's a polyatomic ion.
is it -6?
So X minus 6 is -2.
Oh, 4.
Yeah. So there you go. So your carbon here, oops, is actually a +4. Okay. Number 8. What do you know? Like, which one do you know? One of them you absolutely know. What is it? Okay. Has an assigned charge. What is it? 3? Yeah. So aluminum has an assigned charge of 3 on the periodic table. So we can go ahead and give it the same oxidation number. But give me another element whose oxidation number we know. Oxygen, which would be -2. So we don't know what sulfur is. Agreed? 2 ways of doing this. You can either add up all the oxidation numbers to 0, or this is the sulfate ion. So you could add up the oxidation numbers to the charge on the sulfate ion and solve for sulfur that way. It would be a little bit easier. Does that make sense? Either way, you're going to get the same oxidation number. So if I take sulfur and I label it an X, plus, I have 4 oxygen. The oxidation number on oxygen is a -2. On your periodic table, what is the charge on sulfate? -2. So this is X minus 8 is a -2. So what would X be? 6. So sulfur has an oxidation number. Oops, I keep doing that. Of plus 6. Okay? Because that's a polyatomic ion within a compound. Okay? Okay. Any questions on this before I go on? Okay, let's come down here. Yikes. Okay. When you're given a reaction, we're going to start labeling. Let me make this bigger so that I can kind of show you what we're going to do. Here I have a reaction, okay? And in order to figure out what is oxidized and what is reduced, meaning what's accepting electrons and what's giving them up, you have to assign them oxidation numbers. This is elemental iron. What is the oxidation number on something that's in elemental form? 0. So we're going to put a 0 above it. Okay. Cu plus 2 is a monoatomic ion. So that means its oxidation number is the same as its charge, which is plus 2. So you're going to put a plus 2 above it. Okay. Then you've got Fe plus 2, also a monoatomic ion. So what would its oxidation number be? Plus 2. If there's a charge on the paper, then that's its oxidation number. Does that make sense? And then Cu solid is also elemental copper, so we would just put a 0 above it. Okay? So first you assign the oxidation numbers. Then you're going to partner up this Fe with Fe plus 2 on the right, and we read them from left to right. Okay? So if you're going from a 0 to a plus 2 oxidation number, bless you, the oxidation number is increasing. So I'm just going to write that the oxidation number went up. So that means we are losing electrons because you're losing negative charge. Does that make sense? When you lose electrons. So that's why your charge goes up. So if there's a loss of electrons, that means oxidation is occurring. So that means this Fe solid is oxidized. And that happens when the oxidation number increases. Okay? And then I'm going to partner up Cu plus 2 with Cu on the right-hand side. I read it from left to right. Since I'm going from a plus 2 to a 0 oxidation number, my oxidation number is decreasing, and here there is a gain of electrons. So that means Cu plus 2 is reduced. You only write oxidized and reduced on the reactant side. Okay, you will never write it on the product side because there has to be an exchange of electrons between reactants only. Okay. Once you assign them as being oxidized and reduced, then you can take it one step further. If something is oxidized, we call it the reducing agent. And if something is reduced, we call it the oxidizing agent. Okay? And there's a mnemonic that can help you remember what's oxidized and what's reduced. It's called Leo the Lion goes Gur. Okay? Leo stands for loss of electrons, is oxidized. GR stands for gain of electrons, is reduced. Okay, let's take a look at the quick check on the next page when you're ready. Okay, with the person sitting next to you, take a look at the questions and let's see what you guys come up with.
How many electrons are lost by each ion? So iron, right? Yeah. Plus 3. So it loses 3, right? Oh wait, gained or lost? Okay, so they're lost. Wait. Oh, that's true because it becomes negative. Wait. Okay.
Already.
Okay. Our electron gained or lost by each other. What the hell? The best thing would be
Okay, so you guys are going from a +3 to a 0 oxidation number on iron. So it says it's reduced. So gain of electrons equals reduction, right? So here we are gaining. Okay, right? Because when you undergo a reduction, meaning your oxidation number is being reduced, it's going down, okay? So if I'm going from a +3 to a 0, how many electrons do you think are being gained? 3, okay? So I'm gonna put 3. How many electrons are gained or lost by each aluminum? Okay, so aluminum is going from a 0 to a +3 oxidation number. It says we're undergoing oxidation. Remember that Leo is loss of electrons, means we're being oxidized. Okay, so we are losing. Okay. How many electrons are being lost by each aluminum? 3. Okay, so aluminum is actually transferring 3 electrons. Each aluminum is transferring 3 electrons over to iron. God bless you. Okay, how many electrons are transferred total? Look at the coefficients. Yeah, 6. Because you've got 2 aluminum atoms. Okay, so each aluminum atom is transferring 3. Did anything happen to the oxide during this process? No, nothing happened to it. Oxygen in this compound is a -2. And it's also a -2 in the aluminum oxide. So absolutely nothing happened to it. Okay. Any questions? Okay.
Big one, I guess. It looks old. Yeah.
Okay. So on the previous page, I showed you that the substance, I keep doing that, the substance that was being reduced, we call an oxidizing agent. So that means when you assign something as being reduced or undergoing reduction, you would write oxidizing agent underneath it. And then the substance that is being oxidized is the reducing agent. And we're going to practice this on the next page. Okay, so the last page, we turn over. Let's take a look at these practice problems right here. Okay. So let me do number 2 with you first. Okay. We're going to assign oxidation numbers first. Okay. Here I have strontium. That would be elemental strontium. What's its oxidation number?
0.
0. Okay. Then we have FeBr3. Bromine is a halogen. You know that most of the time, halogens have an oxidation number that's the same as its charge, which is -1. What would Fe be? +3. Because you've got 3 bromines at a -1. Ignore the coefficients. Okay? Over here on the product side, I've got elemental iron. So what would its oxidation number be? 0. Here I have bromine, again, halogen. Assign it its usual oxidation number, which is a -1. That means strontium would be +2. And strontium is also an alkaline earth metal, so you know it's +2. Okay? Now we're going to partner up the strontium together because that oxidation number changed. It went from a 0 to a +2. Okay, so that would be a loss of electrons. Is that oxidation or reduction? Oxidation. So strontium is oxidized. Bromine didn't change its oxidation number, so we ignore it. Okay, but the Fe went from a +3 to a 0, so it went down. So that means a gain of electrons. So that means Fe is, yeah, it is reduced. Okay, so whatever is oxidized, that is called the reducing agent because it reduces the other reactant, bless you. And then whatever is reduced, we call that the oxidizing agent. Okay. You can abbreviate these things as RA for reducing agent. And you can abbreviate oxidizing agent as OA if you'd like. Okay? Now, technically, if you have an ionic compound like FeBr3, technically the Fe plus 3 is reduced. Does that make sense? But if it's a molecular compound, you have to state the whole thing because it doesn't break apart into ions. So why don't you guys do number 4 and let's see what you come up with.
So P5000, right? Because it's
Yes, elemental phosphorus.
yeah. So and then
So it goes from
this would be
to 0,
so this goes
oh yeah, plus 3 is
so it's
wasn't it plus 0? Because phosphorus is 0.
Phosphorus is a non.
Yeah.
So assigned hydrogen is usual charge.
So then pH or P. So phosphorus will be negative.
I have one.
Yeah, but I'm just so confused about which part. Okay.
Oh.
Okay, so yeah, I know we did it right, so I don't have to get out of this.
Okay, did you guys get that far when you labeled it?
Yeah.
Okay, so this one's kind of an interesting situation because pH3 is a molecular compound and it is both oxidized and reduced. Does that make sense? Okay, so up here we had an ionic compound with an ion in it that was reduced. Here I have a molecular compound. So since pH3 is a molecular compound, you can't pull out and say that one of the ions is oxidized or reduced because it doesn't have ions. You'll say the whole thing. pH3 is oxidized and reduced. Okay? Which means it's also the oxidizing agent and the reducing agent. It's everything. Does that make sense? Okay. All right. Do you want me to do one more with you? Yeah. Okay. Why don't we take a look at number 3? Okay. So in number 3, for CO, which one of those do you know? Oxygen. Okay. So oxygen has the usual oxidation number of -2, which means carbon would be +2. Okay. Cl2O5, you know oxygen is -2. What would chlorine be? +5. Okay. In CO2, you know oxygen is -2. Carbon is +4. Cl2 is elemental chlorine, 0. Okay. So let's partner up the ones that changed. Carbon went from a +2 to a +4. So there was a loss of electrons here. So that means CO is oxidized. Okay? And then oxygen didn't change, so we're ignoring that. Chlorine went from a +5 to a 0. So here there's a gain of electrons. So that means Cl2O5 is reduced. So if CO is oxidized, it's the reducing agent. I'm just going to abbreviate it, Ra. Cl2O5 is reduced, so it's the oxidizing agent, or OA. Make sense? You have 3 attempts on your homework. It's unlocked. Okay.
I'm actually so glad.
Did you get your math grade back? Yes, I don't know. Wait, I just did. You did? I want to find out like the Okay, wait, you text.
Right now?
Yeah.
I was close to you guys. It was like.
Okay, I'm curious why. Maybe she would have graded that.
We got it. We got nothing. Wait, I just got a grade right now. Wait, what did you get? I wanted to.
Yeah.
You asked me.